Hey everyone, Mr. Kaczynski here, moving into section double D of IXL's Algebra 1 skills. These are all absolute value functions. Today we're going to complete a function table. Not a lot to it, just a matter of following order of operations. So in this case we have f of h is equal to the absolute value of h. So if we do f of negative 3, it's going to be the absolute value of negative 3, which is 3. If we do f of negative 1, it's going to be the absolute value of negative 1, which is 1. If we do f of 1, it'll be the absolute value of 1, which is 1. And if we do f of 3, it'll be the absolute value of 3, which is 3. Notice there's some symmetry there, and we'll get more into that as we get deeper into these skills. All right, let's look at this one, the absolute value of 3z. Okay, f of z is the absolute value of 3 times z. So if we do f of negative 1, we're doing the absolute value of 3 times negative 1, which is the absolute value of negative 3, which is 3. If we do f of 0, then we're doing the absolute value of 3 times 0. Obviously, 3 times 0 is 0, and the absolute value of 0 is 0. What about f of 1? Is this going to be different than f of negative 1? Let's find out. The absolute value of 3 times 1. Absolute value of 3 times 1 is the absolute value of 3, which is 3. So no, not in this case. It's not any different. Maybe that won't always be the case, though. And if we do f of 2, that would be the absolute value of 3 times 2. 3 times 2 is 6, and the absolute value of 6 is 6. I'm sure a lot of you will use a lot of mental math, even though I'm showing a lot of the math right now. Moving on to another one. This time, on that one, we had the multiplication inside the absolute value sign. This time it's outside. All right, so f of z is negative 2 times the absolute value of z. So if we do f of negative 1, then we're doing negative 2 times the absolute value of negative 1. The absolute value of negative 1 is positive 1, and negative 2 times 1 is negative 2. What about f of 0? Well, I mean, we're going to show a bunch of math here, but it's all going to turn out to be 0 anyway. The absolute value of 0 is 0, and 0 times negative 2 is 0. All right, what about f of 1? Negative 2 times the absolute value of 1 in that case. The absolute value of 1 is 1, and negative 2 times 1 is negative 2. And lastly, we'll do f of 2. So that would be negative 2 times the absolute value of 2, which is no different than negative 2 times just 2, which is actually negative 4 this time. So we did get 3 negative 4 or negative values there. So I think in this case it's important to notice that absolute value functions don't always turn out positive. When we multiply that absolute value quantity by a negative, we do get negative values. Let's keep going. This time we have f of m is equal to the absolute value of 8m minus 1. Let's use some mental math this time. If we do f of negative 3, we'd get the absolute value. 8 times negative 3 is negative 24 minus the 1. The absolute value of negative 24 is 24, and 24 minus 1 is 23. All right, what about f of negative 1? We would do the absolute value of 8 times negative 1, which is negative 8, minus 1. The absolute value of negative 8 is 8, and 8 minus 1 is 7. What about f of positive 1? Does this change this time? Sorry. So f of positive 1, that would be the absolute value of 8 times 1, which would be the absolute value of 8 minus 1. The absolute value of 8 is 8, and 8 minus 1 is 7. All right, and one more here. Let's do f of 3. All right, so we're going to do the absolute value of 8 times 3, which is 24, minus the 1. The absolute value of 24 is 24, and 24 minus 1 is 23. Obviously some symmetry there, where the value of the function gets small and then starts getting bigger again. All right, got a lot going on in this one. So our function is that f of r is equal to 8 times the absolute value of r plus 7 minus 5. All right, so we're going to do f of negative 8 first. So it's going to be 8 times the absolute value of negative 8 plus 7, which is negative 1, minus 5. The absolute value of negative 1 is 1. 8 times 1 is 8, and 8 minus 5 is 3. Just following order of operations here. Let's do f of negative 7. All right, 8 times the absolute value of negative 7 plus 7, which is 0, minus the 5. 8 times the absolute value of 0, or 8 times 0 minus 5, which would be 0 minus 5, which is negative 5. F of negative 6. All right, that's going to be 8 times the absolute value of negative 6 plus 7, which is 1, minus the 5. 8 times the absolute value of 1, or 8 times 1 is 8. And 8 minus 5 is 3. Whoa, it went back up to 3 again. So what's going to happen here? Do you think it's going to start getting bigger or start getting smaller? F of negative 5 is equal to 8 times the absolute value of negative 5 plus 7, which is 2, minus 5. 8 times the absolute value of 2, or 8 times 2 is 16. And 16 minus 5 is 11. So look at that, it started getting bigger. So what's going on here is r was getting bigger by 1. What was happening to the value of the function? First it got smaller by 8, and then bigger by 8, and then bigger by 8 again. Did we mess something up? We did not. Okay, negative 7 plus 7 is 0. The absolute value of 0 is 0. 0 times 8 is 8, and 8 minus 5 is negative 5. So we did that right. We did everything right. So we'll start seeing what these graphs look like in future videos. All right, so that should get you started on skill 1 of section double D, completing a function table for absolute value functions.